Hello and welcome. So today we are going to look at one more question from the sample paper, that is question number 32. So this question is from the sampling, that BiasNet sampling, and specifically this the sampling process that this question is given is the likelihood weighting, right? We have different sampling process uh, in the BiasNet, and one of them is the likelihood weighting, right? And the process of likelihood weighting, what we do is that with the given evidence, uh, uh, we do not sample with the given evidence. What we do, we fix our given evidence and we sample over the non-evidence, right? So for the first point is to find in the likelihood is to you will have to observe that what's the evidence that is given in the question. So if you look at this question and if you even look at the samples that have been generated, these samples are S1, S2 and S3 and S4, right? And at the end we have to estimate this probability, right? Probability of B given A is equals to false and C is equals to false, right? I'm assuming that you have already gone through and you have already read this question, so I'm not reading it. So you see in the sample, so if you see we have to find this probability, right? And the evidence is here: A is equals to false and C is equals to false, right? And if you look at this samples, right? So what we have done is that we have fixed our evidence. So this is the evidence, right? Given the evidence, you want to have the probability of this B is equals to true, right? That is what it has been asked, right? And if you look at the sample, so uh, during the sample we have fixed our evidence. So you see that here A is equals to false and here also C is equals to false, and you will find in every sample. So A is equals to false, C is equals to false, and A is equals to false, C is equals to false, A is equals to false, C is equals to false. So this is what the likelihood weighting. So what we try to do is we fix the evidence and we sample over non-evidence. So here non-evidence are the B or D, you can say, right? So now we have to find the weights of these sample, like these S1, S2, S3, S4, right? So since we are sampling over the non-evidence, right, for that we need to keep track of the weight for each sample, right? That is what we have to find. Okay, now once we have the weight of each sample, then we will be able to find the probability of this event, right? So let me first of all find the weight of these samples. So let me first bring this question to my note. uh, okay, so the first sample we have is S1, right? So let's first find. Okay, so now question is how you are going to find the weight, right? Weight of the each sample, right? So uh, weight of the each sample, that is, you can say, weight of the sample, weight of the sample is equal to the probability of the evidence, each evidence given its parent of EI, and you are going to do the product over all the given evidence, right, from maybe 1 to k, right? Here we have two evidence, right? So this one, A and C. A is equals to false and C is equals to false, right? So now let's find the evidence. Let's find the weight of the first sample. So weight of the first sample, that would be product from I is equals to 1 to number of evidence do you have is 2, right? So that will go over 2 till now. We will have to first find the probability that that the evidence, that is A is equals to false, capital A is equals to false, given its parent. So A doesn't have any parent, right? If you look at the Bayes net, that is 1. So let me get rid of this multiplication, because anyhow I will be writing the next one. So that is into probability that the second evidence, that is C is equals to false, C is equals to false, given it has the parent, right, B. So if you see in the sample B is equals to, in the first sample B is equals to false. So we will find this probability when B is equals to false, right? So now you can look up the table. So probability of A is equals to false is this one, that is 4 by 5. So 4 by 5 into probability that C is equals to false given B is equals to false. So here C is equals to false given B is equals to false is 3 by 5, right? So that is going to be 3 by 5. So that will be 12 divided by 25, and we will get 0.48. So this is the weight of your first sample, right? Similarly, with similar process, you can find the weight of the second sample. So let me do that. So here we will have the evidence, probability of evidence, that is A is equals to false, and we have no parent of it, right, into probability that C is equals to false given. Now look at your sample. So in the sample it is B is equals to true, right? So given B is equals to true, that will be, now look at your table, false have 4 by 5 into C is equals to false given B is equals to true. So that will be this one, right, 2 by 5. So that is going to be 8 divided by 25, and it will be 0.32, right? Now similarly we can find the probability of weight of sample of S3, and you see that sample S3 is the weight of the sample of S3 will be same as the S1. You can find out. So that will be 0.48, and also weight of the sample 3 and weight of the sample 4, that will be A, B, C bar. So A, B, C bar. So that will be the weight of equal to the sample of the second sample, that is 0.32, right? Now we have the weight of the each sample. Now we can estimate this probability. So that will be equal to, so probability that B is equals to true given A is equals to false, C is equals to false, will be, so now you will find this probability over your sample data, right? So these are the samples that you have taken it out from this Bayes net, right? So you have sampled these data, right? Now you will have to find the conditional probability, right? And now each sample have the associated weight, right? So we are going to make use of this while finding this probability. So you see this is the conditional probability, so you can condition over A is equals to false and C is equals to false, right? So that will be complete sample, and the what you want is the B is equals to true. So how many out of this sample, how many are B is equals to true? So this S4 sample where B is equals to true, and this S2 sample. right? And the weight of this S2 and S4 is the weight of this S2 is 0.32, so that is going to be 0.32 plus weight of this S4 is 0.32 again, right, divided by weight of S2 and weight of S4, yes, divided by the total weight of the total sample, so that will be 0.48 into, we have 2, so that 2 plus 0.32 into 2. So if you do the calculation, what we will get, let me do that. So that is 0.64 plus 0.96 into 0.64, so that will be equal to 0.4, right? Now you can look at the option. So sample 1 have weight 0.48, 0.32, 0.48, 0.32, and the probability associated of this sample is the 0.4. So this is the correct answer for this question number 32. Thank you.